3x squared minus 8x plus 7 plus 2x to the third minus x squared plus 8x minus 3. So when they simplify this, we're essentially just going to add up like terms. And just as a reminder, we can only add or subtract like terms or simplify like terms. And just a reminder what I mean by that, if I add an x squared to an x squared, these are like terms. They're both x terms raised to the same power, the same degree. So if I have one x squared and then I have another x squared, well, then I have two x squareds. This is two x squareds. If I have an x to the third, let's say I have 3x to the thirds plus another 4x to the thirds. Well, that means I have 7x to the thirds. 7x to the thirds. I can't take an x squared and add it to an x to the third. I cannot simplify this in any way. So this you cannot simplify. Cannot simplify. These are not like terms just because they both have x's. The x's are not to the same degree. So with that in mind, let's look at the x's that are to the same degree. Let's start with the highest degree. So the highest degree, or the highest exponent on an x here, is actually this x to the third here. But it looks like the only one. It's the only place where we're raising x to the third power. So that can't be merged or added to or subtracted to anything else. So let's just write that down. So we have the 2x to the third. And then let's look at the x squared terms. We have 3x squared we have 3x squared over there, and then we have a minus. We have a, or we could view it as a negative x squared over there. So if we want to simplify it, we can add these two terms. We can add, let me just write it down. So we can add 3x squared to negative x squared. So I'm just rearranging it really right now. But I'm putting the like terms next to each other, so it'll be easy to simplify. Now let's worry about just the x to the first terms, or just the x terms. So you have a negative 8x term right over here. So let me write it over here, negative 8x. And then you have a positive 8x term right over here. So let me write that down. So positive 8x. And then finally, let's look at the constant terms. You could view those as times x to the 0th power. And the constant terms are, you have a positive 7 over here, so plus 7. And then you have a negative 3 over here. You have a negative 3. So all I've done is I've really just used the commutative property of addition to change the order, or addition and subtraction, to change the order at which I'm doing this. But I've just rearranged the thing so that the like terms are next to each other. But now we can simplify. So we have 2x to the third, nothing to simplify that with. But then if we subtract, if we have, let me do that in that same blue color. If we have 3x squared, and from that we're taking away an x squared, well, we're only going to have 2x squared left. So that's going to be plus 2x squared. And then over here, if we have negative 8x's, and then we add 8x's to it, or you could actually swap these around, and you could view it as you are subtracting 8x from positive 8x, well, those are just going to cancel out. So that's just going to be 0. I could write a plus 0 here, but that'd just be redundant. Wouldn't change the value. And then finally, I have a plus 7 minus 3. Well, that is just clearly 7 minus 3 is 4, so I have plus 4. And we're done. We've simplified it. 2x to the third plus 2x squared plus 4.